right? So that's sort of the singularity model. You have to sort of explain where the singularity came from, and you know, from nothing, from nothing you get nothing, right? So it had to come from somewhere, and to say it's just a singularity and it really wasn't whatever, you know, infinite mass, infinite heat, no dimension, no matter, mass or something. I don't think that's really a good idea either. Many dimensions. Well, I mean, I take exception to this too. In string theory, I think it's 10. M theory, it's 11. But to me, there's nothing behind those numbers. It's how you set up the model that you get those numbers, right? I mean, set up the model with some different assumptions and whatever, you get a completely different array of numbers. You know, I sort of look at this as like, you know, if you want to find out the number of dimensions, and it basically could be anything, you could throw darts at a number line, or you could do the chicken model. And the chicken model is you take basically a roll with or like a scroll with a number line on it, like a really large number line, and you have the numbers on it, and you go to a place that raises chickens commercially, like a big chicken's pen, so it's like half a mile long or something. And then you write numbers on it, and you place it down in the middle, right, where the chickens are. And then you come back like 2 or 3 days later or whatever, and whichever number has the most chicken crap on it, you know, that's the number of dimensions in the universe. And one thing it has going for it is that it's actually done by chickens and not physicists. So I think that's a big plus for the chicken model. Just as scientific, right? There's nothing behind it. Just as scientific as string theory or some of these other theories. So I think it's pretty interesting. I think somebody might want to give that a try if you have any relations that do poultry farming. We know that collisions happen all the time, right? So here's sort of my favorite, the colossal collision. And this is one of 4 papers I wrote for a PhysCon conference in St. Petersburg, Russia. One of them was accepted, which is the first video I made, which is breaking the light barrier, adding velocities beyond the speed of light. And that was accepted as a poster paper. But the others, one of them that came out of that, you know, my writing was the colossal collision. And what I thought was, what if space is, you know, pre-existing, right? And we don't have a singularity. We have masses. And to the universe, or, you know, to the space that would fit the universe, you might have several different objects, each of which may or may not turn out to be sort of what we conceive to be our universe itself. So it wasn't like a big bang, it was a colossal collision, right? And you can go back and look at Shoemaker-Levy 9. And I think it was 1994, right? That comet that crashed into Jupiter. So, I mean, look at the moon, all kinds of craters. The Earth, we know, had big craters in it. So it's not unusual that things would actually collide. And so this is just another model that takes space as a pre-existing condition and says, what if, you know, we got 2 large objects you know, colliding together. It too would cause a big bang, right? So anyway, so it would also solve the, you know, why if there was a big bang and everything is basically exploding radially out, you know, then why is Andromeda and the Milky Way sort of moving towards each other? So that's a question that needs to be asked. I'll talk more about that in a second, but yep, pre-existing space, boom. Explains it, yep. Okay, collisions can happen all the time, chicken, okay, I think we covered that one. So, but I do want to move off to the other one, which actually entails, you know, this is, the colossal collision is sort of in here, when I said that, let me see, I have to read what I said. Space is a necessary pre-existing condition for matter to explode, expand, or burn. I listed it as Blumdal's postulate. There's that name popping up again. I don't know why, but there it is. Blumdal's postulate. Space is a necessary pre-existing condition for matter to explode, expand, or burn. Right? Basically what that means is no matter what you have, if you have something to explode, if you have something to expand, if you have something to burn, like a cartridge in a rifle burns, the powder they tell you that it burns. I mean, obviously it's so fast it sounds like an explosion, but nevertheless they actually call it a burn. That's why I put it in there, just for the safety's sake, right? So, and then here's my other thought. Without space, nothing can exist, right? Without space, nothing can exist. No matter can exist, not even an electron, or smaller, right? Space is a pre-existing necessary condition for anything, matter, to be there, whatever the reason. So what we get is that actually it's the independence of space, matter, and time. Time, because although we can have relative time, like you look at your watch and it's 4 o'clock, but there's no absolute time. Absolute space, yes. Absolute time, no. So, yeah, so space has to be go back and look at all the explosions, supernova. Space is existing, right? I know I was reading something about the stars, the formation and the life and the death of stars, and the author was saying, well, it's not, space isn't like a firework, going off and expanding. And I said, and I thought to myself, no, that's exactly what it is. I mean, that's exactly what space is there. And I think for matter to exist, it has to be there. Without it, nothing's going to happen. So, yeah, a cosmic seed bursts forth into the space void, not unfolds with this void space, right? In other words, what they're thinking now is space-time. Forget it. The space-time model of the general theory is wrong. No curved space, no bending, no warping, none of that. Okay? So, what was I saying? Right, so it's not like an unfolding, like you take a blanket in a package and just kind of unfold it on your bed. That's not what's happening. What's happening is that space is there. We go back, I mean, where did the mass come from? It had to come from somewhere. Was it, I don't know. Was it pre-existing? I don't know. But it's not like, space-time, ripples of space-time, they don't exist. Gravity waves don't exist. An accelerating universe doesn't exist. And so it's not that space and time and objects and everything is just sort of unfolds together. That's not true. Right? It's not true. That's not the way it happens. They're all independent of each other. So let's see what I got here. No space-time a la GTR, which I just said. Space, matter, objects linked by gravity, right? Everything sort of has, the mass is linked by gravity, not stuck into space like a cobweb, and then the cobweb just expands. That's not what's happening. Okay? The idea really is that, right, the problem with the LIGO experiment was they made the mistake of, well, not only are there no gravitons, right? No. And there is no fabric of space-time, ripples in space-time, no. But where they really made the mistake was in the tubes that they had. And then they said, well, the gravity waves came through and changed the mirrors or just tick the mirrors a little bit, and that way they knew it was a gravity wave coming through there. But then they said it was, in order for that to be true, it has to be space-time. If you can't define space-time, then how can you define what's in that tube if you don't know how to do it? And what they had is a vacuum tube. That's what they had, just two huge vacuum tubes, 4 feet in diameter, 2.5 miles in length. Vacuum tubes. But you can't displace or compress space, right? So that's where the experiment went wrong. They have nothing. But, and it's like our universe too. You can't compress space into a singularity. There's nothing to compress. It has to be just a mass, right? You can't take and put space in there, or any other small little model and say that's space in there. It's not. Space is void. It's emptiness. It's vacuum. There's nothing there. You can't compress space into another little object, and then it doesn't work that way. So when you think of space, think exactly what perhaps Newton and Aristotle and others did before them, right? It's just an emptiness. It's a void, right? So it gives you something to think about. Right, so you can't compress it, so it can't be, it unfolds. It's that whatever that cosmic seed or seeds bursts forth, explodes, 2 or more collides, right? But space is a given, right? So into space, blah, blah, blah. No frame dragging, because there's no space-time. It doesn't work. I mean, it's a going back to the luminiferous ether, the Michelson-Morley experiment, I think like 1888 or 1899. I think one of the worst experiments ever done in the history of mankind. And no web space. It's not like objects are caught in space and space is expanding. And no, the spider web theory. No, that's not any good. Okay, so I think we covered all that. Yeah, without space, nothing can exist, right? Cosmic seed bursts forth into it. So it's not, I'm not sure I really agree with the singularity or any bigger one than that, but if there's 1, there could be 2. If there's 2, there could be 8. We have no idea what's going on. So anyway, all right, let me take this down for a second, and we shall proceed on. My wife and daughter are coming in. Shh. Can you shut the door, hon?